Welcome to Emi-Brain, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Alright, good day students, how are you all doing? In today's class, I'll be showing us how to convert general form of a complex number into polar form. In our last class, we discussed extensively on complex numbers. A complex number does not simply mean something complex. It simply means a number that has two major parts, right? Which are the real parts and the imaginary parts. Okay, I will say generally that complex number can be generally represented as z equals to x plus yi, right? Where x represents the real part, y represents the imaginary part. Okay, for instance, if we have z equals to 2 plus 4i, it means that the real part of z is equals to 2, the imaginary part of z is equals to 4. Alright, okay, so looking at this now, we can be asked to convert this general form into a form called the polar form. The polar form. And the polar form is generally represented as r in brackets cos theta plus I sine theta. Alright? Where the value of r here, r represents the modulus of z, which is equal to square root of s squared plus y squared. Alright? Then the value of our rz is equals to our theta. The word arg talks about the word arguments. It means the word arguments, okay, which is our theta. Also means the word amplitude. The word amplitude. Okay, now the basic idea is that how to convert the general form to a polar form, just like we have here. We have a general form. I want to convert this general form to what? A polar form. Now, how do we achieve that? Is to look at the nature of the general form given. You will find that the general form given falls in the first quadrant. In the Cartesian diagram, we have, the first quadrant, second quadrant, third, and the word fourth. In the first quadrant, we have all, we have sine, we have we have we have what? Tan. The word all means all is positive, meaning sine, tan, and cosine are all positive. Yeah? The word sine means only sine is positive, meaning your tangent and your cosine are negative here. The word t represents tangent. Tangent, it means that tangent is positive here, but your sine and cosine are negative. Then here, it means that your cosine is positive, that means your sine and your tangent are negative in this Cartesian quadrant. Alright? Now, since the value of our x and y, if the general form is z equals to x plus yi, that implies that our x is equals to 2, y is equals to what? 2. The real part is 2, the imaginary part is 2. So that means since both of them, both x and y are both positive, that means they will fall in the first quadrant. When that happens, we're going to bring out our value of x as 2 and value of y as 2. There's an angle formed there. The angle here is called alpha, but the alpha here is equals to what? Theta. Then we have our point of origin. We can call this point A, and this point what? B. Then the hypotenuse is same as your modulus of z. So from point 0 to point A is referred to as r, which is same as z modulus. Don't forget that we define z modulus as square root of s squared plus y squared. Now let's proceed. Now to proceed further, the first is that in the polar form I gave us, the formula says, right, z equals to what? R cos theta plus I sine theta. Then we need two components here. The first component we need is the value of r. Second is what? The value of cos theta. So let's find the value of r. Well, recall that r is equals to what? Z what? Modulus, which is equals to square root of s squared plus y squared. So that means that r becomes square root of 2 squared plus what? 2 squared. So r becomes square root of 8, which is equals to 2 sub what? 2. Now let's find the value of our arc z, which is equals to what? Theta. Okay, now to find the value of theta, we can use any of the trigonometric identities, right? We can either use sine, cosine, or tangent. Reason because the value of the force in the first quadrant says all is positive, right? So I can decide to use sine. So using sine alpha. The word sine talks about the word opposite over hypotenuse. So I'm to use sine alpha, it means I'll consider my opposite divided by what? Hypotenuse. From the word so, this is how to find your angle. Alright, so So sine theta or sine alpha equals opposite over hypotenuse. Our opposite is 2. What is our hypotenuse? Which is 2 saw 2. So that means that 2 divided by 2 saw 2. Opposite over hypotenuse. When this cancel this, so we have what here? Sine alpha equals to 1 over saw 2. So what do you have here? Sine alpha equals to 0.7071. So to find alpha, we're going to look at sine inverse of 0.7071. So alpha is actually 45 degrees. Now one thing you should take note is that whenever the value of z falls in the first quadrant, alpha equals to theta. There are different values of theta in the quadrants when it comes to complex number in polar form. The first one is that when value of z falls in here, just like this example, the value of alpha is equal to what? Theta. Because there is no rotation of angle, right? So our alpha here is what is theta, right? Then, secondly, the value of z falls in here. This value here is called alpha. Here is called what? Theta. Our theta is what? 180 minus alpha. When the value of z falls in the first quadrant, to find the theta, we use 180 minus alpha. Now, what if the value of z falls in the third quadrant? What do you have here? Yes, our alpha. Our theta is measured from here to here, which is theta equals to 180 plus alpha. Okay? Theta equals to 180 plus alpha from here down to this point. Are you following? Now, if you notice this rotation, we cover from here to here, then from here to here 180, then there we have what? Alpha, which is this. Now, what if the value of your z falls in the fourth quadrant? What do you have here? We have our alpha here, then here will give us 360 minus alpha for the value of our theta in the fourth quadrant. You must always take note that your value of alpha is always in the negative x-axis or the positive x-axis. But your value of theta is measured from your positive x-axis down to the hypotenuse line. Alright? Okay, now let's proceed now. Now we have seen that the value of alpha, since z falls in the first quadrant, we want to say that alpha is equals to theta equals to what? 45 degrees. Therefore, our theta is 45 degrees. Now the next is that your theta angle must have to be in radian, unless otherwise stated in your exam. Or if you are solving any exam that have to do with polar form, your angle theta must be in radian. And how to convert to radian is simple. What we have to do is to multiply this 45 with 1 radian. Radian represents this symbol, okay? Okay. Then divide by what? 180. Now what do we do? 45 can go in this step, that will give us 1. 45 and 180, that will give us 4. So the value here becomes pi over 4. Pi over 4. Now we have been able to solve for our angle theta. Our angle theta is pi over 4. Now the next is to fix in our formula. Then the formula says, recall that z equals to r cos theta plus I sine theta. So that means the value of z becomes r we got is 2 sort 1, 2 in bracket. We have our cos pi over 4 plus I sine pi over 4. This is the final answer. So this expression is called the polar form of a complex number, which is also represented as r6 theta. The sixth form of this is this. So if I'm to put this in this form, a value of r represents what here? 2 sort 2. Okay? This is what? Our theta here is pi over 4. Therefore, we can say that z is equal to 2 sort 2 in bracket cos pi over 4 plus I sine pi over 4 all equals to 2 sort 2 is pi over 4. Final answer.